Good afternoon, everyone. Welcome to today's webinar, How to Deliver Production Quality Parts at Prototype Speed, hosted by Practical Machinists and presented by Okuma. If you have any technical difficulties during the webinar, a recorded version of the presentation will be sent to all attendees following today's event. At the end of the presentation, feel free to chat your questions during our live Q&A session. I'd now like to introduce Mark Bissell, Senior Applications Engineer and Manager of New Business Development at CamWorks.
Thank you so much, Jessica. And thank you for all attending. And I'd like to get started here right away. Let's jump right in on it. So we're here to talk about how to deliver production quality parts at prototype speeds. Let me begin. I'm the Senior Applications Engineer for Geometric, the makers of CamWorks. You can see a little bit about my experience there, 30+ years of CNC manufacturing, global manufacturing consultant, and I have lean manufacturing and Six Sigma training and experience. And I work for Geometric. Geometric is the maker of CamWorks. We also make some other desktop products, software products as well. And you can see we are a worldwide company with over 4,600 employees. We have global delivery centers throughout the US and Europe, China, and India. And our portfolio, in addition to the software products that we manufacture, we also offer engineering services and manufacturing engineering services, as well as automation services. So I'd also like to introduce with me today is the President and CEO of NCAB Products, Neil Porter. Neil, are you with us?
Yeah, I'm here.
So Neil is with us, and Neil is a veteran mechanical engineer and designer. He's also a certified SolidWorks professional, as you can see, and he's been a CamWorks user for many years. And Neil was kind enough to join us to discuss the product and his success and how he's able to deliver production quality parts at prototype speed. And Neil, I mentioned, is the president of NCAD, and NCAD now has a new domain or division called milletnow.com. Where they offer fully CNC machined parts in 1 to 3 days. And so you can see there a little bit about NCAD, and Neil, maybe you could tell us a little bit about NCAD.
Sorry about that, I had to take off mute. Yeah, basically founded in 1996, had a DBA incorporated in 2000. We have done, we've had contracts in the LASIK world. We do a lot of commercial parts, a lot of government subsidiary parts, everything from design, full fabrication, machining, all the way through to welding, assembly, finished paint, all in-house. We're kind of a small project house. My ranks only, I don't have quite 4,600 employees. I have just shy of 20. So. We're good at what we do, but we're very small and nimble, which also helps us be agile enough to do the quick turn delivery stuff.
Terrific. Okay. So let me move on then. Recently, NCAD Products set up a new domain or division called milletnow.com, and NCAD is a ISO 9001 certified manufacturer. And the challenge Neil was facing was to rebuild the business some after the downturn in 2008, and also to expand his business from being a local or regional manufacturer into a nationally recognized manufacturer. And so to do that, what he did was he leveraged SolidWorks and CamWorks to dramatically reduce the time to market and it allowed him to be able to create this new domain called milletnow.com to deliver fully CNC machined parts in 1 to 3 days from receipt of order. And now as a result, milletnow.com now accounts for about 45% of NCAT's business, and it's now serving 34 different states throughout the nation. It's probably more than that now, Neil, my guess would be. And this is the website that, or domain that Neil had set up. And this is currently available on the web for those that are interested. And it's www.milletnow.com. So what we're here to talk about is how Neil was able to do this and how he leveraged SolidWorks and CamWorks to deliver parts and at faster time to market. So you can see here, up here at the top of this diagram, the first step is to reduce the programming time. And then also to have faster machining and cycle times. And also to adjust to design changes if there are any. And then start the cycle over. So I'm often asked why CamWorks, what's so great about CamWorks? The first thing is that you can reduce your programming time by up to 90%. And you can have faster machining and cycle times by up to 80%. You can cut your setup times in half and improve the safety of your CNC machines. And improve the quality and consistency of the parts that are being manufactured. And you can also use CamWorks to automate and customize your system. So let's look at the first thing here, reduce programming time by up to 90%. And how CamWorks is able to do that. It uses feature-based machining, first of all. And feature-based machining is critical to reducing the programming time. Similar to parametric feature-based mechanical design and what feature-based mechanical design did for design engineers, CamWorks feature-based machining does that for the CNC programming. It's seamlessly integrated, so it's right inside SolidWorks or Solid Edge, and it runs directly inside the interface. It's also CAD independent in that it can take even imported models and treat them exactly the same way as it would native SolidWorks or Solid Edge files. It uses automatic feature recognition to automatically recognize machinable features on the part. And it uses knowledge-based machining in order to generate operations automatically and choose the correct feeds and speeds and cycles, depth of cuts, and so on for the machining. Feature-based machining is important because it creates true 3D machinable features, not chains or profiles the way traditional CAD systems work. And you can also create complex 3D features, wrapped features like the ones you see there, but also 3D or 3-axis surfaces, faces, and so on. And CamWorks uses a feature tree, very similar to SolidWorks or to other CAD systems. And then it also has assembly-based machining support. So you can create a full assembly of multiple part fixtures, and you can check for collision avoidance and so on using CamWorks assembly-based machining. So it's seamlessly integrated inside the CAM system. It runs right inside SolidWorks, and all of the CAM data that's developed from using CamWorks is stored directly in the SolidWorks part or assembly file. And CAMWorks was the first certified gold CAM partner of SOLIDWORKS. Similarly, it's seamlessly embedded inside Solid Edge. And CAMWorks was the first fully embedded CAM system inside Solid Edge so that you can program your parts directly inside Solid Edge without ever having to leave the Solid Edge environment. I mentioned that it's also CAD independent, so it can take files from various CAD systems, and an imported file, whether it be inside SOLIDWORKS or Solid Edge, is treated exactly the same way as CAMWorks as a native file. So it can take files from a number of other CAD systems as well. And it also has industry standard support for STEP and ASIS and Parasolid files and so on. CAMWorks uses automatic feature recognition. It's fully automatic. It'll recognize over 20 different types of machinable features. This is much more robust than most feature recognition. It's not just for holes or pockets. It'll find slots, bosses, and a myriad of other machinable features on the part. It creates fully associative features. So these machinable features are fully associated with the model. It allows the design model and the manufacturing model to become one and the same, so that the toolpaths will update automatically with changes that are made to the design file. And it creates machinable features that are independent of the features that are used to create the CAD model. This is important because the features used to create the CAD model are not always the ones that need to be machined. And it ends up allowing you to have faster programming time as compared to traditional systems by 80% or more. And you can see here it supports OD turning, ID turning, and CNC milling features as well. So it can find all the different types of features that you see identified there. CAMWorks also uses knowledge-based machining, and it uses the patented technology database in order to generate operations and create toolpaths. Using the technology database, you can capture and reuse your best practices. So this improves efficiency and plant-wide consistency. This means all the programs are going to be generated the same for the different types of features that are being machined. And it's fully customizable. So you can capture the best practices of your best programmers and machinists and store them inside the database so that those techniques, machining strategies, tools, and feeds and speeds are used automatically when CAMWorks sees a particular feature in a particular type of material. And this eliminates repetition through standardization. So you do it once and you can use it again and again and again. And this is the most advanced knowledge-based machining technology that's available. Inside the technology database, we can define machines, materials, feeds and speeds, tooling, and so on. So let's now take a look at the product and how it works. So here's a part that I have inside SOLIDWORKS. And this could just as easily, this happens to be a native SOLIDWORKS file. You can see the tree over here, the SOLIDWORKS feature tree over here. This could just as easily be an imported part as well. CAMWorks is an add-in to SOLIDWORKS. So once it's been installed, we end up with a CAMWorks menu. We also have a CAMWorks toolbar that gets added. In addition, there's also the CAMWorks command managers. So we have a couple of command managers that we add to the interface as well. And those are great for when you're first learning and getting used to the system. And we also add a couple of tabs to the SOLIDWORKS property manager. So we add a tab for the CAMWorks features and a tab for the CAMWorks operations. So I'm going to take this part and begin by using automatic feature recognition to automatically recognize the machinable features on this part. And now the system is looking at the model and extracting the machinable features, identifying those features that can be machined on this part. And it automatically added them to the CamWorks feature tree. So you can see here, it found the outside of the part perimeter. It also found the hole in the center here because it's a different size than the other holes that are in the part. It also found this group of small holes as well. And because all those holes are the same size, it automatically grouped them together so that I don't have to individually go around and pick all these holes. Likewise, it also created a group of these counterbore holes. And you also see here that it identified the pockets in the part as well. Now that it's identified the features in the part, the machinable features, I can go ahead and use knowledge-based machining to generate the operation plan for machining these features automatically. So I'll go ahead and do that. And now it's using the technology database to choose the operations, tools, feeds and speeds, and so on for machining of this part. And these are feeds and speeds, strategies, tools that I've stored previously into the technology database. It comes with a standard set of tools and strategies assigned, but I've also customized it a little bit for my purposes, for my preferred method of machining. And you can see here it automatically generated all these operations for machining of the part. Each of these operations is an individual operation for the machining. And I can drag and drop these into a particular order. This is going to be processed from top to bottom, this list. And so that's the sequence of machining that's going to occur. And sequence of machining is always important. So what I want to do here is sort these. So for example, I could drag and drop these into a particular order if I want them in an exact order. Or I could also go ahead and sort them. And so what I'll do in this case is use the sort operations function. And what I can do is I can use this list here to drag and drop the operations into the desired order. So for example, what I might want to do is do all the rough milling and all the finish milling before all the center drilling and drilling. I hit apply here, and it'll sort the operations into that order, and it does that automatically. And if I can save this scheme if I want to use this scheme and reuse it automatically as well. Now that I have them in the correct order, I can go ahead and generate the toolpaths. And now I can go ahead and simulate the machining of this part. And of course, I can stop this, single step through it. I can also change the speed of the simulation. Okay. And you can see the part fully machined. I can also compare the cut model to the original design model. And I can see that everything is in green, and that's good. That means that everything has been correctly machined. If there was remaining stock, it would be in blue. If for some reason there was some instance that caused a gouge in the part, I would see it in red. But you can see where everything is in green and everything looks good. You might wonder about the stock as well. You can see where I have it set up. It puts 100 thousandths around the part automatically for me, around a bounding box of the part. Maybe I want to hold this in a vise, for example, so I might want to add a little stock to the bottom of the part. I can do that here, just by clicking here. And you can see the stock size here that I would need to have in order to machine the part. Now that I've added a little bit of stock, we can see watch the simulation one more time, and you can see that it'll leave a little stock on the bottom for me to grip on while I'm holding it in the vise. So you can see it's very easy to use CamWorks, and it's very quick to be able to machine parts. I can go ahead and generate G-code now for the machine that I like. And it asks me if I want to replace it. And I can single step through the G-code, or I can just go ahead and play and let it generate the G-code file for the machining. And here's that G-code file that we could then send to the machine for the machining of this part. I mentioned about how the design and manufacturing model become one and the same. What I could also do is go ahead and pick this part and let's make a change to it. So for example, let's make a design change. And what I'll do is I'll change this value right here to 4 inches, for example. And you'll see where the part changed pretty dramatically in terms of the size of the pockets and so on. As soon as I go back to either of the CamWorks tabs, the system knows that it's been changed. And now it asks me if I want to rebuild it. And in this case, I want to do a full rebuild because I have made a change that affects the toolpaths. The light rebuild is if I made a simple change that didn't affect the toolpaths. And it goes ahead and generates the new toolpaths to the new change. And now I can go ahead and simulate. And now we'll get the new part machined with the changes made. And again, I could add stock to the bottom of the part if I needed to for machining or for work holding purposes. Okay. Now this is a relatively simple part, but there's also, CamWorks can be used to machine much more complex parts. I know Neil has machined much more complex parts. Also, one of the things I might point out is that CamWorks also supports multiple configurations within CamWorks or within SolidWorks as well. So for example, if I have another SolidWorks configuration, and for example, I have a larger plate here that's more complex, I could also have a corresponding program, and in this case I do, for the larger plate as well. And all this is stored in the single SolidWorks part file. So you can even support multiple configurations from within the part file. Okay. So let me go back now. And what I'd like to do is just introduce Neil and talk to Neil a little bit about about NCAD and what CamWorks has done for him. So Neil, are you there?
Yeah.
Neil, can you tell us about NCAD a little more and what type of CNC machines you have and what type of materials you're cutting?
We run all of our mills. Our Haas mills, we also have a Haas lathe, as well as we run Thermwood routers. My mills vary from 12 by 16 all the way to 64 by 40. We do primarily aluminum. We do some steel, some 4140, stainless, titanium. We pretty much do almost everything, but what work finds us is primarily 6061 aluminum, 7075, 7050, materials like that. We also cut nylon, Delrin, everything across the board. It's just, it's job shop work, so we cut what comes in.
And how long have you been using CamWorks now?
I think this will be our 12th year. We started in 2002. We brought in CamWorks and our first machine to actually run CNC machine our own urethane molds was where we were going with it. And it slowly evolved into, we started becoming we got a contract to do some thermoforming. So we started cutting our own 3-axis thermoforming tools on our mills. And that's why we have such large mills, is we would cut some really big patterns. And then we, offline, when we weren't cutting patterns, we started milling parts. And one thing led to another, and here we are. And now we're up to like nine different styles of CNC machines, and we primarily cut, plastic and metal. And
tell me a little bit about the CamWorks product. How's it been for you over the years, and how's it improved? Or tell me about that.
Yeah, sure. It's been, it's been a great product. It was great out of the gate. We got a full demo when we purchased, and at that time our focus was on molds. So we were able to, our applications person with our salesman was able to take a part that we had done, and it was a little itty-bitty part, but it had 4,200 facets within the little itty-bitty mold. And this was 12 years ago, so the computer was not very thrilled to do it. And it was able to do it. Since then, things have improved. Strategies have changed. We've gotten into the tricoidal milling with the volume mill add-in. Lathe has improved. I've been called many a times by the applications engineer here locally that my enhancement request was in this release, and I forgot that I put an enhancement request in because I think I have many. So, they definitely take the user input with the request for, hey, I wish it did this, or this is a pain, and they make improvements to the product. It may take time. It may take till they have enough people that say this is an issue for it to make it to the top of the list. But, we've definitely seen some vast improvements over the 12 years that we've been involved in it.
Tell us about how CamWorks has helped MillItNow.com. You're able to deliver parts in 1 to 3 days, CNC machine parts, often within 1 to 3 days. And I'm wondering about how long does the average part take you to develop the program using CamWorks?
Okay. Yeah, basically, NCAD in the downturn, we were looking for ways to subsidize our business and get ourselves more work, more market share, and we came up with the Mill It Now concept to go market just machining because we were such a diverse company. We would have never even considered going down that road if it had not been for our comfort and our expertise in and around SolidWorks and CamWorks. It was definitely, we already had the tool in-house. We already knew that we could take care of that facet before we even started building the site. I don't think we would have even considered building the site and offering those types of deliveries if it hadn't have been our comfort and confidence in our CAM software. Our parts vary greatly. If you guys check the website out, you'll see in the gallery, they are everything from little widgets to huge, 9 by 9 by 20 surface machined. Some are multi-axis, and they vary in complexity and they vary in delivery. Not everything is going to be a 3-day ship. But the nice thing is even on a large part that might take 70 or 80 hours to machine, we can probably put a tool path on it in 30 minutes, an hour, and actually get that block of material up in the machine and start with our first setup and start the majority of the material removal in the roughing process while we concurrently cam the rest of it on the fly. So, a small part, easily a half hour to an hour. A more complex part, it may take the majority of, it may take a shift, but we're talking a really big part, a lot of features, a lot of how am I going to hold it? It's that tight tolerance. How are we going to process this? It's more how everybody's going to have to machine it, not necessarily the speed at which you could cam it. So, but yeah, I mean, we're very good at it, but it's also it's a great tool. Yeah. That answer your question?
Sure. Yeah. And what about the customer service? Is it again for you?
Yeah. CamWorks uses VARs. Our value-added reseller is Access Manufacturing Systems. They've been my VAR since day one. I've actually had the same salesman the whole time. I've had 2 different applications guys locally. And when you call in for assistance or help, you may get someone in a different location throughout the country, but they know the product. They're usually able to answer your question. Sometimes I have gone over and beyond because of the complexity of some of the stuff we do. Sometimes we do discover something that's a very, very, very deep, problem that they can't address, that they'll send it to you guys on the west side, and someone else will answer my question. But the support's very good. The tech support, the helpline is very good. Just don't be embarrassed that if you're having a hard time with something that's simple, don't just call. Just call and ask the stupid question. There are no stupid questions, and they'll help you.
Certainly. And would you recommend CamWorks to those listening?
Of course. I mean, we own multiple suites of different software, and each in its own right is a tool, and each has its strengths. And this is we are in it every day. We use it for the majority of our work. I actually have 3 other suites of software that we very rarely touch anymore, because with the enhancements and the improvements, CamWorks has stepped up and exceeded what we could have done with the other software prior. So
Thanks.
Yes, I would highly recommend it.
Terrific. Thank you so much. I'm going to move along quickly now. We only have a few minutes left here, so I want to give a little bit of time for some questions. And I mentioned about reducing cycle times, and Neil also made mention of the CamWorks VoluMill product. CamWorks VoluMill can increase production by as much as 500%. It can reduce tooling costs by as much as 90%. It avoids broken tools and the resulting crashes. And it significantly reduce your maintenance costs as well. It's easier on the machine, it's easier cutting, and it can remove material very fast. And this is a tool primarily for rough milling purposes. And it'll also increase the life of your machine tool. If you're wondering how it works and how it can be so much faster, over on the left you see where in the past we used to take a 50% step over. And the 50% step over with a smaller axial depth of cut is what we used to do in the past. What we've learned since then is over on the right you see where if you'll take a smaller radial step over, rather than 50% step over, more like 15% step over, a much smaller step over, then you can use the full flute length of your cutter and take a deeper depth of cut. And you can remove more material faster this way, and you can typically triple or quadruple feeds and speeds as a result. Another thing that we learned was the ideal cutting conditions. So if you look at the upper right quadrant there, you'll see from 12 o'clock to 3 o'clock where the cutter is climb milling. This is ideal, the ideal cutting conditions. In the past, we used to use what we called offset boundary roughing toolpaths. and those tool paths had some problems. The initial cut was 180 degrees from 9 o'clock to 3 o'clock, you see over on the right. Then lower left, you see where the links between the cuts were also 180 degrees. And the feeds into corners were the same, were likewise, they took more, it was from 10 o'clock to 2 o'clock. So you see how these are not ideal cutting conditions that you see in the upper right. We really want to keep it within that 12 to 3 o'clock area, and that's what VoluMill does for us. So you can see as a result over on the left, traditional offset boundary roughing, it increased cutter load in the areas red, and the result was we had to slow down the whole process in order for the tool to survive. Otherwise, the tool just simply wouldn't survive. Now, using VoluMill and trochoidal type milling, though it's actually better than trochoidal milling in many ways. You'll see here where the ideal cutting conditions are maintained, and the result of that is that we can maximize the feeds and speeds and depth of cuts for the entire roughing process. So here's some results. Before VoluMill, you can see where they were cutting 625 Inconel with a 1/2 inch ML, and they were going at 2 inches per minute and 35-minute cycle time. After VoluMill, then they were able to speed up to 30 inches a minute and reduce the cycle time down to 7 minutes. And you notice the small axial depth of cut, deeper axial depth of cut, the smaller radial depth of cut, the second line there. And the bottom line was an increase, 400% increase in production and a 75% reduction in tooling costs. This is likewise for titanium. So here's an example of titanium where they were able to cut at, previously were cutting at 6 inches per minute, and the cycle time was 80 minutes. They were able to cut at 100 inches a minute in titanium, and they ended up with a cycle time of 30 minutes. And you notice the increase, notice the tool life also increased by 10 times. So they were getting 10 times better tool life as a result. It's because they're using the full flute length of the cutter, and they're getting even wear throughout the cutter. So 166% increase in production, a 90% reduction in the cost of the tooling. And finally, here's an example in 1018 steel. This one I'm going to show you a video on in a moment. So this, typically you cut 1018 at about 3,200 RPM, 40 inches a minute. This is what's recommended using a carbide 4-flute M-mill, 1/2 inch M-mill with 1 inch depth of, or 1 inch flute length. And using VoluMill, we were able to up that to 9,000 RPM and 360 inches a minute. Notice how the cycle time was reduced from 21 minutes to 4 minutes. So an 80% reduction in cycle time, a 70% increase in tool life. And here's a video of that part actually being cut. So here you can see the smaller radial step over, the axial step over. This is 1018 steel being cut at 9,000 RPM, 360 inches a minute, 1 inch deep with a 4-flute 1/2 inch M-mill. It's pretty impressive. And I know, Neil, you use the VoluMill quite a bit as well. Finally, we also can reduce setup times, and we now have the new CamWorks virtual machine. CamWorks virtual machine is a true G-code virtual machine simulator. It has full collision detection for the machine, and it will show us the full kinematics of the machine, the fixtures, the tooling, the stock, and so on. And the simulation is driven directly off the G-code. The result is that you can improve safety and avoid broken tools and collisions, and reduce your setup time with first-time right programs. Here's a short video on that. And you can see here where there's a 5-axis part being machined in CamWorks Virtual Machine. It also supports dual channels, so it'll support machining on dual turret lathes, integrexes, mill turns, those sorts of machines. And you can see here where there's a 5-axis simulation or simulation of some 5-axis toolpath inside SolidWorks. And then we'll go ahead and launch CamWorks Virtual Machine. And in order to do that, of course, it wants the G-code first, so we need to post-process the file because the simulation is driven directly off the G-code. So here's the G-code file being generated. And then you'll see the machine simulation. We're a little short on time, so I'm going to run by this now. And last but not least, what I wanted to mention was the CamWorks APIs that allow you to be able to customize and automate as well. So CamWorks also includes application programming interfaces that allow for interfacing and development. And here's another quick example of a company called CP Carrillo on the West Coast. They make pistons and rods, and they used CamWorks and SolidWorks to reduce their design time by 95%, reduce their CNC programming time by 75%, and reduce the rework and scrap by 20%. Overall lead time was reduced by 85%. And this is important because based on 10 years of empirical data from the US and Canada, companies that reduce total manufacturing cycle time by 75% or more will typically more than double in productivity, reduce the break-even point of the facility by 20%, have a 250% higher margin than the industry average, and grow at a rate of 300% faster than the industry average. So don't you want to be one of these companies? Okay, we'll work to the question and answers.
Thank you so much, Mark and Neil. We did have a few questions come in, but if anyone else has any questions, go ahead and chat them either in the chat box or the Q&A box. So one question that we're getting is, how hard is it to learn CamWorks? Are there any training videos available?
There sure are. We have Solid Professor videos just like SolidWorks. So we have a whole set of those that are available, and they're available at no charge to the customers.
Great. Another question that came through says, can CamWorks find all those features when the model is done in Pro-E Wildfire 4?
Yes, in imported models, Pro-E Wildfire 4, we might need to save that model into a step file. For example, I know Pro-E Wildfire has a couple of different options. There's probably several, but by saving that into a file format that could be read into SolidWorks, then we can run it inside CamWorks, and yes, it'll find the machinable features exactly like you saw on an imported model as it will on a native SolidWorks or Solid Edge file.
Great. Another question is, are the post processors customizable?
Yes, they are customizable. We have what we call a UPG, which is a program used to customize the post. It's user-friendly, and it allows you to make changes to the post processors as well. So yes, they are, and And as well, the resellers and Geometric also can help with post-development.
Also, does CamWorks, or I'm sorry, do you have to have SolidWorks or Solid Edge in order to run CamWorks?
No, we also have a standalone version as well. It has its own solid modeling front end to it, and so you can also run it as well.
Mark, it seems like this technology would only work well for a family of parts and wouldn't work well for a job shop environment. Is that the case?
Yeah, that's definitely not the case. I mean, Neil can attest to that. He's a job shop. What you're actually doing is building a library of features. And so those features, whether they be pockets, holes, or bosses or slots, those features you're going to see again and again in various parts. And by determining what the best methods are for your shop for machining those and storing those inside the technology database, you can then quickly automate the process. And that's the advantage of using CamWorks knowledge-based machining.
Great. And finally, where can we find more information about CamWorks?
Yeah, I have it up there on the screen. Go to www.camworks.com.
Great. On behalf of Practical Machinists and CamWorks, I'd like to thank you all for participating. If any of your questions weren't answered, we do have a record of them, and I can send those directly to Mark, so you can ask your questions to him. I'd also like to thank Mark and Neil for sharing their knowledge and expertise with us today. And again, look out for the recorded version of this webinar, and then Mark's email so that you can send him any questions or comments about the webinar. Thank you all for joining today.